Now from unit to Green's theorem. The statement of the Green's theorem. If u comma v comma dou u by dou y and dou v by dou x are continuous and single valued function in the region R enclosed by the curve C, then integral over C u into dx plus v into dy is equals to double integral over R dou v by dou x minus dou u by dou y into dx dy. Now the problems for the Green's theorem. The first question, verify Green's theorem in the xy plane for integral over c 3x minus 8y square into dx plus 4y minus 6xy into dy, where c is the boundary of the region given by x is equal to 0, y equal to 0 and x plus y equal to 1. So this is the question. Now the formula for the Green's theorem, integral over C, means the relation between line integral and the double integral. U into dx plus v into dy, which means integral over C, single integral, like line integral, which is equal to double integral over R dou v by dou x minus dou u by dou y into dx dy. So in this given question, first we have to identify what is u and what is v in this. Now, according to the formula u into dx plus v into dy, now in the question, the coefficient of dx is equal to u, which is 3x minus 8y square, and the coefficient of dy is equal to v, which is 4y minus 6xy. Now, as per the formula, dou v by dou x minus dou u by dou y. So, in this the given u, we have to differentiate u partially with respect to y. So, dou u by dou y is equal to, there is no y term, it is 0, minus 8 into y square differentiation is 2y, 2 into 8 is equal to minus 16. And in this given v is equals to 4y minus 6xy and dou v by dou x, differentiate v partially with respect to x, which is equals to minus 6y. Now the formula dou v by dou x minus dou u by dou y is equals to here minus 6y plus 16 into y into dx. Here already we found the differentiation also. Dou v by dou x is equal to minus 6y, dou u by dou y is equal to minus 16y. So minus 6y plus 16y is equal to plus 10y into dx dy, and we need the value of a double integral, that means the limits of x and y. So according to the question, the limits are, equations are given, x is equal to y, y equal to, x is equal to 0, y equal to 0 and x plus y equal to 1. Already we know what is the value of x plus y equal to 1. It is the straight line passes through 1 comma 0 and 1 comma 0 and 0 comma 1. So this is the line for x plus y equal to 1, and this is the equation of y equal to 0, and this is the equation of x is equal to 0. This is the given value. So in this we can able to find out the value of x and y values. So in this curve, x is equal to 0. This is the equation of y-axis, x is equal to 0. This is the equation of x-axis, y equal to 0. So x is equal to 0 to, from this straight line x plus y equal to 1. So we can take it as x is equal to 1 minus y, and the value of y equal to 0 to 1. So it is clearly that y equal to 0 to 1 and x is equal to 0 to 1 minus y into, and here after the subtraction 10y, this is 10y into dx dy. 10 is the constant. Now y dx into dy. As per the property of the integration, limit is y integrate with respect to x. So y is the constant. Dx is equal to x. Close the limit from 0 to 1 minus y. And upper limit of x is equal to 1 minus y. So 1 minus y minus 0 into dy. So y into 1 minus y, and multiply y minus y square into dy. Now integrate this. Y into dy equal to y square by 2 minus y square into dy equal to y cube by 3. Close the limit from 0 to 1. And now apply the upper limit minus lower limit. So 1 by 2 minus 1 by 3 is equals to, this is the LCM 6. 3 minus 2, that is 1 by 6. 10 by 6 is equal to 5 by 3. Hence, the answer for RH is equal to 5 by 3. So, in this way, we can go for LHS. So, we have the formula integral u dx plus v into dy. Now, this is the value u dx plus v into dy. So, this is the u value and the v value. So, as per the uh, given equation which is mapped in the figure, so there are three axes along the direction OA, along the direction AB, and along the direction BO. First of all, first case along the direction OA, here the equation is y equal to 0. If y equal to 0, what is the value of our dy? Dy is also 0. So now we can take the value of x limits. So x limits from 0 to here, this is 0 comma 0, x comma y, and 0 comma 1 comma 0, it is x is equal to 1. Therefore x limit is 0 comma 1. So 0 to 1 into, now y equal to 0, substitute here, this is 0, and also y equal to 0 means dy equal to 0, the second term the entire value is 0. So 3x into dx, 3 into x into dx is equal to x square by 2, close the limit from 0 to 1, which is equal to 3 by 2. Next, for the equation AB, here the equation is given x plus y is equal to 1. So we can take either x is equal to 1 minus y or y equal to 1 minus x. If it is y equal to 1 minus x, what is dy? Dy is equal to minus dx. So substitute those values in this. So y is equal to 1 minus x. After differentiate, dy is equal to minus dx. Substitute those values in this question. Now, here this is the value. So y equal to 1 minus x, we can replace y equal to 1 minus x. This is y square. So 1 minus x whole square into dx plus 4 into the value of y is equal to 1 minus x minus 6x into again the value of y equal to 1 minus x into dy is equal to the value of dy equal to minus dx. Now, now take the limit for x limit. So x limit is from a to b. Here 1 comma 0, which is x is equal to 1. Here 0 comma 1, which is x is equal to 0. So the limit for x is equal to 1 to 0. So 1 to 0. Take all the values to convert into y, convert into x. So we have the line integral of x and integrate with respect to x. After simplify this equation, there's the whole thing. It is minus 14x square plus 29x minus 12 into dx, and integrate now. Minus 14 is the constant. X square into dx is equal to x cube by 3. Close the limit from 1 to 0 plus 29 into integral x into dx is equal to x square by 2. Close the limit from 1 to 0. Minus 12 is the constant. Integral dx is equal to x from 1 to 0. So now upper limit as x is equal to 0 minus lower limit as x is equal to 1, and simplify. We have the answer 13 by 6. So this is the integration of the second case. Now we can move on the third case along the direction BO. Here x is equal to 0. If x is equal to 0, the value of dx also 0. So substitute x and dx value in this question. So this is the question. So x is equal to 0, this is 0, and dx is equal to 0, the entire value is 0. And here x is equal to 0 and this is also 0. So we have the value for the third case. So now only for 4y into dy, and the limit for y limit. Here 0 comma 1 is the value of b, and 0 comma 0 is the value of b. Now we are going to take in the y limits. So 1 to 0. So here y equal to 1, here y equal to 0. So 1 to 0. Now integrate. 4 is the constant. Integral y into dy equal to y square by 2. Close the limit from 1 to 0. Now 4 by 2 is 2. Close the limit. Upper limit as y equal to 0 minus lower limit as y equal to 1. So it is 4 by 2 into 0 minus 1 equal to minus 1. So minus 1 into 2 is equal to minus 2. Now the overall LHS along the direction OA plus AB plus BO, after we added all the three values, it is 5 by 3. Already we verified that LHS also. RHS means a double integral of the RHS also we have already 5 by 3. Hence both answers are equal. Hence LHS equals to RHS. Therefore Green's theorem is verified. Next is this is the next question. Evaluate using Green's theorem, where C is the square formed by the lines x is equal to plus or minus 1, y equal to plus or minus 1. So now as per the formula for the Green's theorem, integral over C u into dx plus v into dy is equal to double integral over r dou v by dou x minus dou u by dou y into dx dy. So now first of all, we can identify the coefficient of dx is equal to u and the coefficient of dy is equals to v. So now let's move on the right hand side, dou v by dou x minus dou u by dou y. So u partially with respect to y differentiate 1 plus dou u by dou y, x square is the constant, differentiation of 1 plus y is equal to, this is 0, 0 plus 1 equal to 1, and differentiate u, v partially with respect to x cube differentiation is 3x square. Hence for the right hand side, so this is dou v by dou x 3x square minus dou u by dou y is equal to x square. 3x square minus x square equal to 2x square into dx dy. So now and also the limits of x and y values are given. X is equal to plus or minus 1 and y also plus or minus 1. So minus 1 to plus 1, minus 1 to plus 1. 2 is the constant, x cube by 3, minus 1 to plus 1, and upper limit of x is equal to plus 1, minus of lower limit is minus 1. So minus into minus plus 1 by 3 plus 1 by 3 is equals to 2 by 3. Already constant is 2. So 4 by 3 into integral dy. Integral dy is equal to y. Again close the limit from minus 1 to plus 1. 1 upper limit of y is equal to 1. Minus of lower limit of y equal to minus 1. So minus into minus plus 1 plus 1 equal to 2. 2 into 4 is equal to 8 by 3. So the overall, the surface integral of the right hand side is equals to 8 by 3. Now we can, so we got the right hand side. In this question, this is not a verification, only for the evaluation of the Green's theorem. But the evaluation of the Green's theorem, we have the right hand side answer is 8 by 3. So whatever the answer, it is the same thing will be coming for the 8 by 3 for LHS also, which means the line integral also 8 by 3. So we need not go for verification of this question. It is asked only for the evaluation. So whatever the right hand side answer, which is equivalent to left hand side, which is nothing but the line integral of the question, it is 8 by 3. So now we can practice for the third question for your reference. And in the next part, and instead of u comma v also, it will be, sometimes it will be given p q and m comma n also. If p comma q means dou p by dou y minus command dou q by dou x, we can use. For example, instead of u comma v, it will be given p q also. So if it is p q are the notations, how to use the formula, integral over c, p into dx plus q into dy is equal to double integral over r dou q by dou x minus dou p by dou y into dx dy. Hence Green's theorem. The next is the Gauss divergence theorem. Here Gauss divergence theorem. Now the statement of the Gauss divergence theorem, the surface integral of the normal component of a vector function f vector over a closed surface S enclosing volume V is equal to the volume of the integral of the divergence of the f vector taken throughout the volume V. means the surface integral is, as we know, double integral over s f vector dot n cap into ds, which is equal to triple integral over v del dot f vector into d. Which means the volume of the divergence. The divergence formula is del dot f vector. Volume is equal to triple integral. So volume of V, therefore triple integral over V, divergence is equal to del dot f vector into, here it is volume under over V. So if it is V means it is dV. So this is the formula. So the surface integral between the integral of the surface between volume. So for surface and the volume between double integral and a triple integral is the formula for the Gauss divergence theorem. And interesting, the first question, verify Gauss divergence for the function f vector is equals to 4x into z I vector minus y square into j plus yz into k vector over the cube, x is equal to 0 to 1, y equal to 0 to 1 and z equal to 0 to 1. So the formula for the Gauss divergence theorem, double integral over s f vector dot n cap into ds is equal to triple integral over v del dot f vector into dv. Now f vector, and this is the given f vector 4xz into I minus y square into j plus yz into k vector. Now del dot f vector. So del dot f is equal to, we have the formula for del, dou by dou x into I plus dou by dou y into j plus dou by dou z into k vector dot f vector 4x x z into I minus y square into j plus yz into k vector. So now we have to take the dot product between these two, del dot f vector. So I dot I is equal to 1, so dou by dou x of 4xz plus j dot j is equal to 1, so dou by dou y into minus y square plus dou by dou z of, and k dot k is equal to 1, hence yz. So differentiate now partially with respect to x, y and z. So now differentiate partially with respect to x, 4xz is equal to 4z. Differentiate partially with respect to y of this minus y square is minus 2y. Differentiate partially with respect to z of yz is equals to y. So minus 2y plus y is equal to minus y. Hence 4z minus y is the value of del dot f vector, which means the right hand side of the divergence of the f vector. Now we have to take the volume of this divergence of f vector, find the triple integral, and the limits are also given. X is equal to 0 to 1, y equal to 0 to 1 and z equal to 0 to 1. So now RHS, this is the formula, and we know the given limits are x is equal to 0 to 1, y equal to 0 to 1, z equal to 0 to 1, because of we are going to finding the volume. And also del dot f vector, here we already found 4z minus y into dv. Here the value of dv is equal to dx dy dz because of the volume of the given vector v. So now integrate with respect to x first. 4z into dx is equal to 4zx minus y into dx, so minus xy into 0 to 1 dy dz. So now x limits from 0 to 1, so 4z minus y into dy dz. Now integrate with respect to y. So 4z into dy is equal to 4zy minus y into dy is equal to y square by 2. Y limits from 0 to 1 into dz. Now upper limit of y is equal to 1. So 4z minus y is equal to 1 by 2. So 4z minus 1 by 2 into dz. Now 4z into dz equal to 4z square by 2 minus 1 by 2 is the constant. Integral dz equal to z. Close the limit from 0 to 1. And z equal to 1, so z equal to 1, 4 by 2 is equal to 2 minus z equal to 1 is the upper limit, it is 1 by 2, so 2 minus 1 by 2 is equal to 3 by 2. So we have the volume of the right hand side, the entire right hand side of the answer is 3 by 2. Now we can move on the LHS. So we have the formula for the LHS, double integral over s f vector dot n cap into ds. So now what is f vector? It's a given vector is f vector 4x into z into I minus y square j plus yz into k vector dot n cap into ds. ds is the surface integral. So in this, So it is the clearly the question is for x is equal to 0 to 1, y equal to 0 to 1, and z equal to 0 to 1. It is clearly it is a cube. So it is a 3 dimension. So there are 6 cases are there. So in this is a given. So there are 6 phases. First of all, there are instead of s is equal to double integral over s1, s2, s3, s4, and s5. So in the first one, in the first phase along s1, here we can take it as A, E, G, D is the first phase of S1. And in the another phase is instead of this is the second phase. Second phase means here O, B, F, C is the second surface S2. And for the third phase, third surface ES3, we can take it as here. So in this one, we can take it as third surface. E, B, F, G is the third surface. And also similar to this, see opposite of this similar is A, O, C, D is the fourth, means OA. OA anything we can take. A, O, C, D is the fourth surface. And in the fifth surface, this one, that means O, A, E, B is the OA. So S5 either it is given already Z no. So this is D, G, F, C is the fifth surface, and similar of this E, O, A, E, G, E, B. O, A, E, B is the last surface. Okay, now so one by one we can see all the unit normal vector and what is the ds value and whatever the double integral limits. So first surface A, E, G, D. Here n vector is equal to I vector. N vector equal to I, therefore f vector dot n vector, because the formula double integral over s f vector dot n cap into ds. So here n cap is equal to I vector, f vector dot n cap, this is f vector, I dot I equal to 1, other things under I dot j equal to 0 and also I dot k equal to 0. So we take only the coefficient of I only, because of only f vector dot n cap, here n cap is equal to I dot I is equal to 1. So other entries are other dot product between I dot j and I dot k equal to 0. So 4xz into 1 is equal to 4xz, and here the value of x is equal to 1, and f vector dot n cap on s is equal to, here is that x is equal to 1. What is f vector dot n cap is equal to 4z, and here ds, because of the formula is ds. Ds is the surface integral. Here it is the yz plane. So for yz plane is dz equal to dy dz. Hence, overall formula for double integral over S1 f vector dot n cap into ds is equal to, already we have f vector dot n cap is equal to 4z into ds is equal to, this is the yz plane, so dy dz, and also the limit for y equal to 0 to 1, z also 0 to 1, which is given in the limit. And also the similar of this O, F, C, D, here n cap is equal to the opposite of this, I is equal to minus I, and f vector dot n cap also 4x minus of 4xz, and the value of x is equal to 0. So if x is equal to 0, x is equal to 0, here minus 4xz, no, x is equal to 0 means the entire answer is 0, and also this is ds is equal to dy dz plane, and if it is x is equal to 0, after we substitute the value of f vector dot n cap into ds also it is 0. And the third case EBFG, here the value of y is equal to 1, because here it is y is equal to 1. So here n cap is equal to j vector, so j dot j equal to 1, so f vector dot n cap is equal to minus y square. So now minus, here y equal to 1. So y equal to 1 means here j dot j equal to 1, it is minus y square, and the effective dot n cap on s is equal to now here y is equal to 1 now, so minus 1 square equal to minus 1, and the ds is equal to, this is xz plane. For xz plane is d is s is equal to dx into dz. Hence, the value of effector dot n cap into ds is equal to minus 1 into, this is the xz plane, so dx into dz, and the limits for x is equal to 0 to 1 given, and also the limit for z equal to 0 to 1 given. And in the fourth phase, OADC, in the fourth phase, OADC, here the value of y equal to 0. So value of y equal to 0, effector dot n cap also, the y equal to 0 means the entire value j dot j equal to 1. So anyway it is minus y square, y equal to 0 means the value of effector dot n cap on s is equal to 0, and also the integration also 0 for the fourth case. And in the fifth case, here DGFC. For DGFC here, n cap is equal to k vector. So k dot k only we have to consider. Now here effector dot n cap, this is the effector equal to yz into k vector dot k vector. K dot k equal to 1, so the value is equal to yz. And here the value of z equal to 1 for DGFC, the value of z equal to 1 already given. So if z equal to 1, the effector dot n cap on s is equal to y. Hence, here ds is equal to dx dy, which means here it is xy plane. So for xy plane, ds is equal to dx into dy. Now substitute in the double integration, that means the surface integral. So x is equal to 0 to 1, y equal to 0 to 1, and also effector dot n cap on s is equal to y into dx dy. And also the opposite of this, here the opposite of here AEBO. For AEBO, here AEBO, the n cap is equal to minus k vector, and also effector dot n cap is equal to minus. So if it is minus means it is minus yz, and the value of z equal to 0. So if z equal to 0, the entire integration also 0. So now we have to go for the integration. S1 plus S2, S2 already it is 0. Here, this is the 0. So we can find the value of S1, 0 to 1, 4z into dy dz. So first integrate with respect to y, z into y. 4 is the constant, integral dy is equal to 1, y limits from 0 to 1. Now y is equal to 1, upper limit minus y equal to 0 is the lower limit. So 4 is z into dz, 4 is z into dz, 4 is the constant, integral z into dz equal to z square by 2 and 0 to 1. Now upper limit of z equal to 1 minus lower limit of z equal to 0, 4 by 2 is equal to 2. And in the third and the fourth case, here third and the fourth case, here 0 to 1, 0 to 1, minus 1 into dx dy. So minus dx into dy, minus dy into dz. Here. X is it. So y equal to 1, it is the xz plane. So for xz plane, this is xz, not y. So integral dx is equal to x limit from 0 to 1. Anyway, 0 to 1 equal to 1 only, minus 1 is the constant. Again, it is dz, integral dz equal to z, and z limit from 0 to 1. So after the 0 to 1, 1 minus 0 equal to minus 1. So for the S3 surface, the value is equal to minus 1, and S4 answer already we have proved that it is 0 only. So next we can go for the fifth surface. So for the fifth surface already we proved that 0 to 1, 0 to 1, y into dx dy. So this is the xy plane. So y into dx dy. Here y is the constant, integral dx is equal to x limit from 0 to 1, and Now x is equal to 1 is the upper limit, minus x is equal to 0 is the lower limit. So 1 minus 0 equal to 1. Now y into dy. So now upper limit of y x is equal to 1 minus 0 equal to 1. So y into dy. Integral y into dy is equal to y square by 2. So y square by 2 and y here. Let's see what is the direction of this y into dx dy. There is no xz. Y into dx dy, integral dx is equal to x limit from 0 to 1, so 1 minus 0 equal to 1. Next is y into dy, integral y into dy is equal to y square by 2, and y square by 2, the limit is upper limit of y is equal to 1 minus lower limit. Here it is y, not z limit. This is the y equal to 0 to 1 by the typological error. So here y equal to 0 to, and 1 by 2 is the final answer. And for the sixth surface is 0. Now we can enter all the answers. So here for the first two faces answer is 2, and next three surfaces it is minus 1, so 2 minus 1, and the last two surfaces answer is plus 1 by 2. So 2 minus 1 plus 1 by 2 is equal to, this is 1, 1 plus 1 by 2 equal to 3 by 2. And for right hand side also, already we have proved that the volume of the triple integration also it is 3 by 2. Hence LHS equals to RHS. Therefore, surface integral between f vector dot n cap into ds is equal to triple integral over v. Divergence of f vector means del dot f vector into dv. Therefore, Gauss divergence theorem is verified. Hence, 3 by 2 is equal to 3 by 2. We got the answer. And the second question. Now, with verify Gauss divergence theorem for f vector equal to x square into I plus y square into j plus z square into k over the cube. X is equal to 0 to a, y equal to 0 to b, and z equal to 0 to c. So now Gauss divergence theorem, the surface integral between S f vector dot n cap into ds is equal to triple integral over v del dot f vector into dv. Now f vector given, this is given del dot f vector. As usual, find the divergence of this del vector, the formula dot f vector is equal to x square into I plus y square into j plus z square into k, and after we dou by dou x of I dot I equal to 1, dou by dou x of x square plus dou by dou y of y square plus dou by dou z of z square, and differentiate partially with respect to x, differentiate partially with respect to y, differentiate partially with respect to z. So the answer 2 into x plus y plus z. And now the volume, it is the given limits are x is equal to 0 to a, y equal to 0 to b, and z equal to 0 to c. So now x is equal to 0 to a, 0 to b, and 0 to c. The value of the divergence into dv is equal to dx dy dz. So now 2 into, now integrate z equal to 0 to c, y equal to 0 to b. Now integrate this. So 2 into x plus y plus z into dx. So integrate, 2 is the constant, x into dx is equal to x square by 2, y into dx, y dx is equal to x plus z into dx is equal to x, zx. Close the limit from x is equal to 0 to a, dy into dz. Now upper limit of x is equal to a. So this is the value of upper limit of x is equal to a minus lower limit of x is equal to 0. Next, integrate with respect to y. So a square by 2 is the constant into dy is equal to y plus a constant y into dy is equal to y square by 2 plus a constant is z into dy is equal to zy. and apply the upper limit minus lower limit. Upper limit of y is equal to b minus lower limit of y equal to 0. Now finally it's the line integral. That means z equal to 0 to c, the value of this into dz. So now integrate with respect to z. B a square by 2 is the constant. Integral dz equal to z plus ab square by 2 is the constant. Integral dz equal to z plus ab is the constant. Integral z into dz equal to z square by 2. Close the limit from 0 to c. Now upper limit of z equal to c minus lower limit of z equal to 0. Now this is the value. And finally we take ABC is the common. So ABC into A plus B plus C is the final value of this RHS. Now LHS formula. Now this is the effector dot n cap into ds. So it is given for, it's a cube 0 to a, y equal to 0 to b, and z equal to 0 to c. So there are 6 surfaces. As before we did whatever the 6 surfaces, AEGD and also OBEFC and EBFG and AOCD. So after finding all the 6 faces and integrate, we will be getting the answer is here ABC into A plus B plus C. Hence, the surface integral between effector dot n cap into ds is equal to volume of the triple integration of divergence. Hence, LHS is equal to RHS. Therefore, Gauss divergence theorem is verified. And similarly, for the practice third question, the last theorem is the Stokes theorem. Now the Stokes theorem, the statement, the surface integral of the normal component of the curl of a vector point function effector over an open surface S is equal to the line integral of the tangential component of effector around the closed curve C bounding S. Now integral over C effector dot dr is equal to double integral over S del cross effector dot n cap into ds. Because here the question, the line integral of the tangential component of effector, therefore integral over C effector dot dr. This is the line integral formula. F dot dr is equal to the surface integral of the normal component of the curl effector over the function effector. So now curl F is equal to del cross effector and normal component of the curl vector function effector over on the surface S. So del cross effector dot n cap into ds over on the surface S. So this is the formula. Therefore this is the relation between line integral and the surface integral over the curl effector dot n cap into ds. Stokes theorem. Now the first question. Verify Stokes theorem for effector equal to x square minus y square into I plus 2xy into j in the rectangular region of xy plane bounded by the line x is equal to 0 to a, y equal to 0 to b. So in this question, there is no k vector, so there is no z limits. So according to I vector and j vector only given, so we can go for first del RHS. So surface integral del cross effector dot n cap into ds. Del cross f is equal to ijk dou by dou x dou by dou by dou by dou z, and here coefficient of I. So how to write the third row? F1 vector, F2 vector, F3 vector means coefficient of I is the F1 vector, coefficient of j is the F2 vector. So x square minus y square 2xy, and F3 vector is coefficient of k is equal to 0. So now this we can expand I vector into, now expand row wise, dou by dou y of 0 equal to 0 minus dou by dou z of 2xy equal to 0 minus j vector into dou by dou x of 0 equal to 0 minus dou by dou z of this x square minus y square equal to 0 plus k vector into dou by dou x of 2xy is equal to 2y minus dou by dou y of this x square minus y square. So minus into minus is equal to 2y. So plus 2y. So 2y plus 2y equal to 4y. So 4y into k vector. Hence del cross f is equal to 4y into k vector. Now overall the formula for RHS double integral over S del cross f vector dot n cap into ds. So already we got the del cross f value is 4y into k vector dot n cap into ds. So now here n cap is equal to k vector. And also if it is n cap is equal to k vector and the surface area is equals to ds is equal to dx into dy. So now dx into dy. And k dot k is equal to 1, so 4y into dx dy. Now limit for the given limit for x and y is x is equal to 0 to a, y equal to 0 to b. So x is equal to 0 to a, y equal to 0 to b, and y dx into dy. Now y is the common integral dx is equal to x limits from 0 to a into dy. Now upper limit of x is equal to a minus lower limit of x is equal to 0, a minus 0 equal to a. So a into y into dy. Now 4a is the constant interval y into dy equal to y square by 2 and close the limit from y equal to 0 to b. So as y equal to b is the upper limit minus y equal to 0 is the lower limit, it is b square by 2. So 4 by 2 is equal to 2. So 2a b square is the answer for RHS. Now we can move on to LHS. F vector, this is the given F vector. Formula for LHS is equal to F vector dot dr. This is F vector. Dr is equal to, as per the expansion of dr is dx into I plus dy into j plus dz into k. In the question, there is no k vector, so we can neglect this. So therefore, we can take it as only for dx into I plus dy into j vector. So now F vector dot dr is equal to x square minus y square into dx plus 2xy into dy. Now f vector dot dr is equal to x square minus y square into dx plus 2xy into dy. So now LHS. So there are how many directions are there? So given is x is equal to 0 to a and y equal to 0 to b. So there are 4 directions are there. First along we take along y OA is equal to 0 because this is the x-axis y equal to 0. Equation of y-axis x is equal to 0, x is equal to a and y equal to b. So along y equal to 0, dy equal to 0 because of differentiation of y is equal to 0. So y equal to 0 is dy equal to 0. So we have the remaining value only x square into dx. And the value of x limits, here x is equal to 0 and also here x is equal to a. The limit for x is equal to 0 to a. Now integral x square into dx is equal to x cube by 3. So value of this first case is x cube by 3. It is a cube by 3 is the answer. Next along AB, here along AB, x is equal to a is the question. The given value of means the value of x is equal to a is the AB direction. So if x is equal to a, what is the dx differentiation? It is 0. So if dx is equal to 0, this is 0, entire value is 0 and x is equal to a, so therefore 2ay into dy. Now x is equal to a, dx is equal to 0. Now third direction along BC, y equal to b. So if y equal to b, what is dy? dy equal to 0. So now dy equal to 0, we have to take the limit for x limit. So here x is equal to a and x is equal to 0. Therefore the x limit is a to 0. Now x is x square minus b square into dx. So next after integrate, the fourth case is along CO x is equal to 0. Along x is equal to 0, dx is equal to 0. So now substitute here dx is equal to 0. The first term whole thing is 0 and dy equal to 0. The second term also whole thing is 0. So now x is equal to 0 and dx is equal to 0. X is equal to 0 means the same second term, the entire answer is 0. So we have to go for only the first 3 cases only. So now So now we can integrate. So x square by 2, a cube by 3 is the first case. And here it is 2a into y. So a is the constant, 2a is the constant, y square by 2, and y is equals to b. So b square by 2, 2 also we can cancel, it is ab square. And what is the third case here? 0 to a, x square minus b square into dx. So x square into dx is equal to x cube by 3 minus b square into x. Close the limit from 0 to a. So after we added these three cases, so we have the answer, it is 2a cube 2ab square. Hence LHS equals to RHS. And similarly, this is the second question for the practice.